Hi everyone, hope you're having a good Friday or a good 4-day weekend. But today you have an ed puzzle for homework, so please watch this video. It's going to ask you a few questions and just answer them before moving on. And you do have to complete an iReady lesson this upcoming week. So because the week is short, you only have 3 days, I suggest you get it done over the weekend. So we had just focused on GCF and LCM, greatest common factor and least common multiple. So I just want to talk about problem solving and how we're going to approach that before we do so on Wednesday. So some keywords that are going to come up when you have a GCF problem is greatest, of course, greatest, most, maximum, so those are just some typical ones, but there are also kind of those special problems that don't have the keywords, and a lot of those deal with when we split anything up. Because we're dealing with factors, if you split something into groups, or perhaps you're arranging things into groups, but anytime you have something split, it is dealing with GCF because we're dealing with factors, not multiples, and factors are division. Now, when you have least common multiple, of course you're going to see words such as least, you're going to see smallest, or max, or minimum. Those are the typical ones, but LCM also has some special word problems as well. And that is because it's a multiple, we're dealing with multiple. Some special problems are when things are happening at the same time. So for example, I could say, oh, well, I swim every Monday, and then I swim every Friday. When's the next time that, or I run every Friday, when's the next time that I will swim and run in the same week or day, whatever. So those are any questions that deal with anything repeating. I'm spelling that wrong. Anything repeating or happening at the same time. And I call this the every problem. Because a lot of those problems will have the word every and then every again. It happens this day and then every other day, whatever. Okay, so these are just some keywords, and if you want, I suggest jot them down in your notebook so that you could kind of identify which one it is, whether it's GCF or LCM. So let's take a look at this problem. First of all, I know sometimes it's hard for you guys because you have a Chromebook and it's not on paper, but I still like to underline my important information. So in this case, Lena is making gift bags for a party. She has 24 gel pens, 48 sheets of stickers, and 32 notepads. She wants all the gift bags to be identical, and she wants to use all of the items. What is the greatest number of gift bags she can make, and how many of each item will be in each bag? So this is asking two different questions. It's not only asking what's the greatest number of gift bags she can make, which is the GCF, but it's also asking how much of each item will be in it. So I'm going to organize this as 24, and I know that this is my gel pen, so I'm going to just put gel pens on top to organize. I also know I have 48 sheets of stickers, so I'm going to put stickers on top. And I know I have 32 notepads. Okay, so let's find the greatest common factor of these to make sure that all our gift bags have these items in them. So I see that they're all odd they're all even because they end with 0, 2, 4, 6, or 8. So I'm going to take out a 2. I'm going to factor out that 2. 24 divided by 2, or 2 goes into 24 12 times. 48 divided by 2 is 24. And 32 divided by 2 is 16. Well, again, we have 3 even numbers, so I know that I could keep going with the 2. 12 divided by 2 is 6. 24 divided by 2 is 12. And 16 divided by 2 is 8. Again, they're all even. I could keep going. 6 divided by 2 is 3. 12 divided by 2 is 6. And 8 divided by 2 is 4. Now, because we're dealing with GCF and not LCM, I have to stop because 3, 6, and 4 have nothing in common. So my greatest common factor is, here's my G. I make a G now. My greatest common factor equals 2 times 2 times 2, which equals 8. Which means that the greatest amount of gift bags that Lena can make is 8 bags. Because we organized over here, gel pens, stickers, notepads, if you look on the bottom here, the 3, the 6, and the 4 tells you how many of each will be in each bag. So we're making 8 gift bags with 3 gel pens, 6 stickers, and 4 notepads. So we knew this was greatest common factor due to the keyword greatest that was in our word problem. Now let's take a look at this one. The high school marching band rehearses with either 6 or 10 members. So they have 6 or 10 members in each line. What is the minimum number of people that can be in the marching band? So because it has the word minimum, we're dealing with LCM here. We're looking for the least common multiple. So let's go ahead and put this in the upside down birthday cake. And let's pull out common factors. Well, I know that I could take out that 2 because 6 and 10 are both even. 6 divided by 2 is 3 and 10 divided by 2 is 5. They have no more common factors, so I'm making my bubble L, and the LCM is 2 times 3 times 5. That means that 2 times 3 is 6, and 6 times 5 is 30. That means that the high school, the minimum number of people they can have in the marching band is 30 people. That's the minimum. They could have more than 30, but the least amount of people they could have in the marching band is 30. So last problem. Oh, I forgot to take off my Christmas border. But I have blinking lights on my Christmas tree every year. The green lights blink every 6 seconds. The red lights blink every 4 seconds. And the white lights blink every 10 seconds. When will they all blink together at the same time? So this is those every problems. I don't know if you noticed, but there's a lot of every. Things are happening at the same time. Well, when things are happening at the same time, we're dealing with an LCM problem. So we know that we need to put these in the upside down cake. So we have 6, we have 4, and we have 10. Now, let's go ahead and pull out our common factors. In this case, I see that they're all even, so I'm pulling out the 2. 6 divided by 2, 3. 4 divided by 2, 2. 10 divided by 2, 5. Now, with LCM, we have a special rule. One could be a tag along and go to the party alone as long as 2 have a common factor. But I'm looking at this and none of them have a common factor, not even 2 of them. So the LCM is simply going to be this L. So our LCM, therefore, that's the therefore symbol, our LCM is 2 times 3 times 2 times 5. And I'm going to break it down into 2 separate problems here. 2 times 3 is 6, and 6 times 2 times 5 is 10, which lets me get 60. Therefore, they will blink together in 60, and we're dealing with seconds. The 6 was the 4 and the 10, they were all seconds, so that means our answer is also seconds. So they are going to blink together in 60 seconds. Every 60 seconds, that means they blink together. All right, that is the conclusion of our video. So when you guys come into class on Wednesday, we are going to kind of just recap a little bit and then go right into practice. Have a great weekend. See you Wednesday.